While we've been discussing equations, let's move on to this idea of inequalities. Inequalities are very similar to equations. The only difference is in an inequality, instead of an equal sign, we have an inequality symbol. So the equal sign is replaced with either less than, greater than, less than or equal to, or greater than or equal to. In addition, when I'm solving an equation, I'm trying to figure out the value of the variable that makes the equation true. The same thing is true for an inequality. However, generally equations have one solution, while an inequality is going to have infinitely many solutions. There's going to be a lot of different things that can satisfy the inequality. So we're going to use interval notation to express these solutions. There are two main things with interval notation that we're going to need. And that's the idea that if I have less than or greater than, I'm going to use parentheses. And if I have less than or equal to or greater than or equal to, I'm going to use square brackets. So essentially, parentheses means exclude and square brackets means include. As an example, let's suppose I want to consider all of the numbers x such that 0 is less than x is less than 5. Then I would have parentheses, and then 0, 5, and another parentheses. On the other hand, if I have something like negative 2 is less than or equal to x is less than or equal to 3, since I now have less than or equal to, I'm going to use these square brackets to include my numbers. In addition, we often graph our solutions to the inequalities. When I'm graphing, I'm essentially going to draw a number line. If I'm using less than or greater than, then I'm going to use an open dot on my number line. Less than or equal to or greater than or equal to means a closed dot. So if I go back to my example earlier of 0 to 5, then I could have my number line. I would put an open dot at 0, an open dot at 5, and then I would shade in between. On the other hand, if I think of this negative 2 to 3 with square brackets, then I would draw my number line and put closed dots at negative 2 and 3, and then once again shade in the middle. And these are not the only two possible outcomes. So let's look at all of the possible outcomes that we could have in interval notation and then the corresponding graphs. The first one we've already dealt with, open parentheses a, comma b, close parentheses. So I don't include either a or b. The graph would have open dots on both of those points. The other one I've already considered is a comma b with square brackets, in which case we're including both a and b. So I would use closed dots on both of them. My next example would be the case that we don't include a, but we do include b. So I have a parentheses a comma b square bracket. I use an open dot on a, closed dot on b. And then I can reverse that as well, include a and not b. I could do parentheses a comma infinity. So these are all of the numbers that are greater than a. So I would shade to the right of a, all the numbers bigger, with an open dot on a. If I wanted to include a, so all the numbers greater than or equal to a, I would then use a square bracket on a and a parenthesis on infinity. I could consider all the numbers less than b, so negative infinity up to b. In this case, I would have an open dot on b and shade to the left. And then finally, I could include b and do the interval from negative infinity to b, all the numbers less than or equal to b. So these are all of my possible combinations of a's and b's. So let's look at some actual examples. I want to consider all of the values of x such that negative 2 is less than x is less than negative 1. So the first thing I want to do is interval notation. In interval notation, we always start with the smaller number and then move to the bigger. So we start with a negative 2. Since we have negative 2 is less than x, that means we're going to use an open parenthesis on negative 2. The other number that we're dealing with is 1. And since we're including 1, we need to use a square bracket. So we have parentheses -2, comma 1 square bracket. When we're looking at our number line, we don't include -2, so we'll put an open dot at -2. We do include 1, so we'll put a closed dot at 1. And then we shade in between. So now we have both the interval notation and the graph. Next, we want to look at all of the values of x such that 0.5 is less than x is less than 2.7. So the two numbers we're considering is 0.5 and 2.7. And both of these have a less than or greater than symbol, so we're going to use parentheses for both of them. So I have parentheses 0.5, comma 2.7, close parentheses. When we look at the number line, we're not including 0.5, so we'll put an open dot there. And we're not including 2.7, so we have an open dot there. And then we shade in the middle. Let's do one more example. I now want to consider all of the values of x such that x is less than or equal to 4. So I want x to be smaller than 4, so things like 3, 2, 1, 0, -1, -2. So you can see that we're going down. So I'm definitely going to be considering the interval between -infinity and 4. We always use a parentheses with infinity and -infinity. And since we have x is less than or equal to 4, we need to include a square bracket with 4. So I now have my interval notation. So I have my number line. We're going to include 4, so we use a closed dot. And we want less than 4, so we're going to shade everything smaller than 4. So now we have the graph.